thank you so much for coming here, and also for hosting students here. Next, we have Ruben Mutua. Ruben, unmute and say hello.
Means they want to see you.
Ruben Mutua, yes.
Hello, I have students from St. Bridget's Yomunyu Girls in Kitui County.
Thank you so much. Welcome to the session. Caleb Masinde.
Yes. Good evening, members.
Good evening.
Of Kuya Girls, huh? I'm having a class of 149 girls.
Say hello, hi, students. Okay, thank you. Thank you. Welcome. Maulidi Shikari. Maulidi Shikari. Maulid, the hand was up, saying maybe there is an issue there. So allow me to introduce our presenters of paper 1 and also paper 2. Presenter paper 1 is called Joe Muhindi. He's a senior examiner. He teaches in Kcse High School, and I think much more he will share his credentials much more. And also amidst us, we have our paper 2 presenter called Nikuri Nation, who is in Moigals, Eldoret. Senior Nikuri, if you can say hi before we welcome in.
Thank you. Good evening, members.
Yeah, good evening.
Good. This is Nikuri Nation.
Good evening.
Thank you. It was a good evening. Let us know. So at this point, I want to call in our paper 1 presenter to take the stage. Senior.
Thank you, Senior. Ladies and gentlemen, good evening.
Good evening to you.
This is Mr. Muhindi. Muhindi is a teacher of mathematics at Kcse High School. Muhindi is a senior examiner, mathematics paper 1. I'm glad we are here today. This being our 2nd edition of this webinar. I'm grateful for all of us for having found time to be with us as we share, as we sharpen one another. And remember, we do this for the sake of the learner that we have. So feel very much welcome as we explore maths, as we engage, and as we prepare our candidates for this year's exam. Now, without wasting time, I'll wish to begin our session today. And I hope everybody is able to see.
Yes, it is clear. It is visible.
Yes. I want us to engage in this area. Remember, we've had these children for the last 4 years, and they are now being prepared and sharpened to have their paper, and paper 1 is being done on 4th of November, the year 2025. So as we go through this, my humble request will be that we listen keenly we take notes, and maybe at the end of this presentation, if there is any question to be asked, we can ask, and this is just maybe in the interest of time. And I'm also aware that we have students among us. I want those students to feel welcome. They follow keenly, because as I start off, I want to believe that passing of maths, a student or a candidate for that matter, must take personal responsibility for their performance. So welcome all. Let us engage as we move forward. To start off, I want to begin from the normal things that sometimes students take for granted. And now that some of them are here, let them get this firsthand. And then with the help of us teachers, we should be able to emphasize the same as we move forward. Point number one, before we actually look at those mistakes, point number one, and this a student should be able to take note of, is math is a career subject. All said and done, all the careers revolve around mathematics. So if a student can be able to understand that and have it in his or her mind, then the path or the way to prospering in mathematics becomes easier. Please, my colleagues, this is basically for the learners. We only need to emphasize this to them. Point number two, that math is at the center of the career wheel. That means everything around what they do is maths. Math is the engine on which everything rotates. And I wish that our learners and our candidates put that in mind. Let our learners know that whatever career they want in life should inspire them to love maths. Once they are inspired to love math, whatever career they have in mind, let it be the reason behind their love of math. And once they love mathematics, we can stay assured that our learners are going to do very well. What are some of the factors that affect performance in math? One, the student is supposed to be disciplined. Discipline is a core ingredient in the performance of mathematics. And the discipline, wholesome, will revolve around what does this learner do? How does he do his or her things? How does he or she organize her programs? How does she keep time? Is she responsive to changes in different environments and different stimuli? That will go a long way in enhancing performance in math. Point number two on factors that affect performance in math is motivation. What motivates a learner? Can they find something in them that can motivate them to love maths? Maybe is it what they want to do in life? Or is it maybe the way a teacher is presenting his or her work? So motivation is a key ingredient in performance of mathematics. The next factor is attitude. Now, attitude, the feeling, whatever you see, how you look at mathematics will determine whether you will love that math or not love the math. So it is important for this learner to understand their attitude towards mathematics. If it has been negative, these remaining few days, can they, for the sake of their career, for the sake of their grade, kindly let them, inspire them to change their attitude from a wrong attitude to the right attitude, and all will be well. Another factor, the teacher-student relationship. For math to be done well, then the relationship between the teacher and the student should be very cordial. The teacher should understand the learner. The learner should accept that this is the teacher, and that acceptance and the teacher understanding who the learner is will go a long way in helping this learner do well in mathematics. I said when we began, and I will repeat, that a student must take personal responsibility for their performance. No blame games, no blaming maybe a friend, no blaming a teacher, no blaming anyone else. The personal responsibility, if he has failed or if she has failed to do one or two tasks, then should be able to own up. Once they own up, once they take responsibility that their performance in math is their sole responsibility, then we are on the right track in performing well in mathematics. This learner should be able to at least learn one concept a day. The remaining few days, up to the time they are sitting for maths paper 1, this learner should at least endeavor to learn just one concept daily. And to add on what they already know, this will go a long way in helping them pass mathematics and pass beyond what they thought they could have achieved. Then, once they have learned that concept, let them teach that concept to a friend. Let them share. The best way to compete is through sharing, through cooperation. And that student who is ready to share, this enhances content retention. It will help him remember what he shared. So let us encourage our learners to always be free and share information. They should not be mean with what they know. Then something strange I observed. There are some lessons that the current candidates can learn from the previous candidates. There are those candidates who did very well. There are those candidates who did not perform very well. So when they look at their colleagues who left earlier, be it last year, be it the other year, what can they learn from them? Those who passed, what were they doing that enabled them pass? And those who did not, what is it that they did that made them not pass their exams to expectations? And so, let them be free. Let them always reflect on the characters and the way their colleagues who left previously did their things. If this is done, then these students can comfortably engage the right gears, can comfortably engage in a right way to ensure that they do well in mathematics. Now, our students must understand that there are cultures in life that math fosters. One of them is hard work. Once a student understands that hard work can be seen or can be grooved in mathematics, then that student is a good learner and will go a long way in doing well in maths. must also understand that mathematics fosters persistence. You do something until you get it right. You do it today, you don't get. Do it tomorrow, you still don't get. Do it the following day, you will start getting it until you, at the end of the line, you are able to grasp it. That is persistent. Then next to that is patience. A student must understand that mathematics fosters patience. That if you want to learn, then be patient. Take your time. Don't be in a hurry. Then it's going to work well for them. Maths enhances personal discipline. Students who do well in math, you will find to an extent they are disciplined students, because math brings in that aspect of personal discipline in the way they organize themselves, in the way they even groom, in the way they carry themselves around. You look organization, because math is order in itself. Math is organization in itself. So once the aspect of math is in a learner, then you'll find this learner becomes organized with the time. Now, there are some myths about performance in math, and I want the students who are on board to be keen on this.
Onge kata ng'ama goyo. Yani ji ng'ato ing'eni kanisa cha Sarach.
Hello?
Who is that?
Carry on, senior.
There are some myths about performance in math, and please, the students who are with me, be very keen. Myth number one, that some people are born with a math gene. That there are some people born naturally, these are mathematicians. That is not true. Anybody can do math, and people can learn. As long as you are receptive to learn, then you can do well in math. And I want my candidates who are with me, we have seen grades being transformed from D's to B's. We have seen D's being transformed to S because a student somewhere decided he must or she must learn math. When that happens, then we are good to go. So let them understand that everybody can do maths. Math is not for special people. Young people, young men, young women, ladies, girls can do mathematics with ease as long as they are willing. Myth number two, that boys are better than girls in math. Again, that is not true. We see girls doing very well, better than some boys. We see some boys doing well, better than some girls. So it should not be taken that boys are better than girls in mathematics. So the girls who are here, don't be intimidated that math is a boy thing. No, even you, a girl who is here, can do math and pass mathematics. Another myth, that mathematicians solve problems quickly and never make mistakes. That again is not true. We've seen students who work out things very fast and they end up making mistakes as they work. And these are students who we purport are mathematicians, students who do well, who pass. But you see, they still commit mistakes. In that speed, the rate at which they work, they can easily make mistakes here and there. And those mistakes, we shall look at them in a short while. So let nobody lie to us that mathematicians solve problems quickly and they never make mistakes. You can be slow and sure that whatever you are writing is correct, and beyond doubt, it is the correct thing that has been written. The last myth I want to put across to us, that a great memory is the key to excelling in mathematics. It isn't true. Memory has something to do with rote learning. Memory has something to do with the cramming. And sometimes cramming can cost you a lot. So not everybody who has a great memory can excel in math. Math goes beyond a great memory. Math is persistence. Math is work day in, day out. Math is understanding. Once you understand the concepts, then you are good to go in mathematics. Now, colleagues and my dear students who are here, having said all that, I want to welcome you to Mathematics Paper 1. The code is 121/1. I want us to be keen. I want us to follow closely as we explore this area, and then we see how to sharpen one another, how to build up one another, and all will be well. Math Paper 1 tests concepts that are taught in Form 1 and 2. Mainly. That is the focus of Math Paper 1. The testing of Math Paper 1 is centered mainly, a majority of the questions or a majority of the test items will come from work that is done in Form 1 and Form 2. Math Paper 1 has two sections, Section 1 and Section 2. Section 1, out of 50 marks, consists of compulsory short answer questions of not more than 4 marks each. Section 2, again 50 marks, contains 8 questions, and each question is 10 marks, where a candidate attempts any 5. It is important to take note that sometimes in some fora, we talk of Section A, we talk of Section B, which we want to take as Section A for Section 1 and Section B for Section 2. In maths, we have Section 1. In maths, we have Section 2. Now, in Section 2, it is important that this candidate chooses questions wisely, because this is now where some students lose marks carelessly, the choice of questions. So it is important that they choose these questions wisely. And what you're saying here is that can this candidate, maybe not just Section 2, but right from Section 1, attempt simpler questions first? Questions that require little time to work them out before going to complex questions. Because the way you can rate a question, there are those questions that you can do easily and very fast. There are those that will take some time because they engage your brain. So let them be advised, and the students who are here, usijifanye gwiji. When it comes to performance in mathematics, hakuna ugwiji. Don't go and do questions and you want to show the examiner that you know mathematics. No. Just get those simple ones, the ones that are easy for you, depending on the way you are prepared. And then you can now handle the complex questions much later. Having said that, I want you to understand that avoid canceling your work in Section 1. If you find that you have messed up, please leave that work and start fresh work. Don't cancel work in Section 1. we shall look at its effects as we move forward. But then, when it comes to section 2, be careful to cancel attempted but not needed work in section 2. There are questions you could attempt, and maybe you find the headway is not showing any signs of light. Be careful to attempt. Be careful to cancel that work. You've attempted it, but you don't need it because it's going to cost you. So cancel it. And in canceling, please just draw a line. You have canceled that work. Follow specific instructions in every question when presenting the answer. Every question can come with specific instructions that maybe write this to the nearest this figure, or write this to this number of significant figures, write this correct to this number of decimal places. So students must also be very keen in those areas, because you can carelessly lose that one mark here, and cumulatively you find yourself losing a lot of marks. In your calculations, as you work out, always work with a minimum of 4 significant figures. Up to the end, then go back to the question and find out what are the specific instructions in this question. Then you can do that. Because when you don't work with 4 significant figures, the deviations from the accuracy can be so enormous, and you'll end up missing that mark because of either premature rounding off, you're not using those 4 significant figures. So make sure that as you calculate, the number of significant figures you should use should be a minimum of 4 significant figures. Then show all the steps in your calculations. And this will help you avoid losing marks unnecessarily. Because sometimes, with the advent of the calculator, a student feeds all the information in the calculator and simply now comes and writes the answer, skipping several steps that are supposed to be shown. And yet even the instruction on the cover page of that question paper is show all your steps in your calculations. So for a student to avoid losing marks unnecessarily, let them be encouraged to show all the steps as they flow from the start up to the time they get to the answer. Then for calculations that involve pi or r, the radius of the earth, there are some constants that somehow a question may not have. Don't just pick on your own because you know them offhand. Look for those constants that are either in the mathematical table or are on the calculator. Don't just pick any other. Use whatever is in the calculator. I said when we began that Math Paper 1 tests mainly content that is taught in Form 1, Form 2. Now, when you look at the distribution of marks over the recent past 6 years, you will notice something. Math Paper 1, this schedule here shows Form 3 and Form 4 work that has been covered in the last 6 years in Math Paper 1. In 2019, in Section 1, there were only 7 marks from Form 3, Form 4 work. And in Section 2, there were only 3 questions. Fast forward as you climb up to last year, the year 2024, in section 1, there were only 9 marks in section 1 from form 3, form 4 work, and only 3 questions in section 2. What does this tell you? That a student who is well-oiled, prepared in form 1, form 2, like last year, if we take, for instance, last year, a student who was just prepared well in form 1, form 2, then would have scored 91 marks in math paper 1. Because in section 1, you would have had 41. In section 2, because there are only 3 questions, that means the other 5 that you can do is basically form 1, form 2 work, you have 50. 50 and 41 gives you 91. Maybe due to human error here and there, because of we are human, maybe that deviation of maybe minus 2 or so marks. That's why I'm saying, students, sometimes we want to do well, but there are a few things that you need to critically look at. And this goes on to our colleagues. Let us also share and sharpen these students in some of those areas. It can really help. The form 3, form 4 work that appeared and has appeared continuously over those years are matrices, trigonometry 2, where the sine and cosine rule are tested, differentiation, and area approximation. So armed with this information, then we can be able to guide our learners in the proper way of handling these questions. Now, we talked about cancelling of work in section 1. I want us to look at this example, a very common example. This is a question on foreign conversion, and a student is supposed to work out. Student A does his work that way. This is a student who understands what he is doing. Step number 1, converts from the foreign currency to Kenyan currency, gets the first mark. The second mark converts from now the Kenyan currency to foreign currency, earns a mark. Then the last mark, the accuracy mark, he gets. Student B. This is a student who is not sure of what he's doing. He makes the first attempt, which apparently is correct, but unfortunately cancels, and then goes for the second attempt, which unfortunately is not correct, and leaves that. So the examiner will mark that. This that is cancelled in a back in Amnayo, this student loses those marks. But if this student had done it as student C, amefanya hapo, that one apparently wrong, but then remembers and then does the correct thing. The work that is done correct is what is marked. That's why we say, please don't cancel your work that is done in section 1. You could be canceling the correct work and you leave the wrong work for marking. So let the students be advised and let them be careful. In section 2, we are talking about not canceling attempted but not needed work in section 2. These are candidates. He has attempted all the questions in section 2. Where he got the time, nobody knows. But apparently, when you look at that performance, this is not a poor student in mathematics. This is a student who knows maths. But because he messed up and did extra questions, the first 5 in section 2 are the ones that are considered. That's why you look at question 22, question 23, question 24, those are extra questions. And it has been written there, EQ. What does this mean for this learner? That he ends up getting only 21 marks. 21, yet this is not a poor student. 21 marks in section 2. But if he had not done question 17, 18, and 20, or had attempted and cancelled, then his mark is coming to 44. That's why we advise, let them cancel a work that is attempted, but they don't need it. It can affect their performance. When it comes to construction, using a scale that is not provided, and sometimes this happens when the student fails to interpret the scale that is provided. The student is booked for misread and loses 2 marks. And it's very, very painful, because you can imagine maybe a question of construction, maybe in section 1, 4 marks, losing 2 marks. It's a very painful experience for that candidate. So let us train our learners to interpret the scale correctly. And this interpretation of the scale, when you look at that question, this is the most difficult scale for most candidates to interpret. That using a scale of 1 to 100,000 represent the information on a scale. So my colleagues, kindly let us narrow down as we prepare these learners for this exercise on 4th of November. Let them learn scale interpretation, and especially a scale as shown on this slide. From that question, you are supposed to locate points. And from that question, the location of points, the source of reference is point A. Point B is located from point A. Point C is located from point B. Point D is located from point C. If point B is located correctly, according to that question, a student earns the first mark. Point C located correctly, the student earns another mark. Then point D located correctly earns another mark. Then according to the scheme, then that completion of that quadrilateral earns the final mark. But if the location of B is not correct, the location of C will not be correct, because it is coming from a wrong located point B. Point D will not be correctly located, because it's coming from a point C that is not located correctly. Therefore, a student will lose all those marks. So, advice here is, let this learner begin from where he is starting from. And this is just a skill that can be learned with the patience, with the time, it's a skill that the learner can learn, measuring angles, using the ruler, using the pair of compasses. It is something that a student can learn and know how to work it out. When it comes to scale drawing and bearing, all nothings must be parallel. Like if we refer to our question, the nothing at A should be parallel to the nothing at B, parallel to the nothing at C, parallel to the nothing at D, to make those points correct. And these parallel lines, you will realize sometimes because of orientation, maybe my north may be a little bit slanting as shown in the second pair of arrows. So whatever the case, as long as you indicate the first arrow in a given direction, then all the other nothings must be parallel to that one. But if you end up with a scenario like this, these are not parallel. And therefore, this can easily cost location of points when now using that diagram to get some answers wrong. So it is important for us to insist on the learners that all the nothings should be parallel. Like in this case here, these ones are not parallel. Learners should understand that bearing can be given in terms of one, true bearing, and true bearing has 3 digits. Or 2, compass bearing, for example, south 37 degrees west, or can be given in terms of direction, e.g. due east. The bearing of point B is, point B is due east of point A, something like that. Let them also be conversant with this type of presentations in bearing. We talked of, or earlier on, I had hinted on not being keen on specific instructions in every question when presenting the answer. Again, this is a normal scenario, very common, but the instruction is down here bold, to the nearest rand. So a student will work out this student A, who has done his work. And we see the answer has been rounded off to the nearest rand. Student B has done everything correct, but has forgotten to round off that answer, loses that 1 mark. Very unfortunate. So let the learners be encouraged to be very keen on specific instructions that a question carries. Very, very important for them. And this will make them avoid losing these marks carelessly. You know, we said a mark lost here, another mark lost elsewhere. They reduce the tally of marks a student can score in an examination. The problem of premature approximation. The instruction in that question is calculate, correct to 1 decimal place, the area of that triangle. You've been given the measurements. Now, student A does it correct, knows what is supposed to be done, does everything, the answer he has presented correct to 1 decimal place. Take note of AB. That's where the problem will arise. The value of AB in this question is 6.3851. So student A has used it that way. He has met the threshold of not less than 4 significant figures. He's using it. He's getting that. But now, look at student B. The value AB 6.3851 has decided to approximate it prematurely, has rounded off to 3 significant figures. That's where now the PA now comes in. At that point, a student is booked, gets the answer. That answer is correct, that's 7.7. But because he approximated prematurely, he will not get the 3 marks. He will end up getting 2 marks because of premature approximation. So let these learners be very, very keen when it comes to premature approximation. It is not allowed. Now, student C, this one has now even approximated or rounded off this value to 1 decimal place. And that rounding off is even affecting the answer. So in as much as we have booked these students, but then the answer is wrong, we shall not penalize this student again. But let them be advised, avoid premature approximation. And that will help them build marks as they work out. Another mistake, and we've seen this affecting these students, omitting evidence of body mass in evaluating integers and fractions. The question is this: without using a calculator, evaluate. How do you carry out this evaluation? Evidence of body mass is important, but look at how these students have performed. Look at how this student has performed. There he has the numerator. We're seeing the numerator the way it is, and then at the tail end, we are seeing the correct value for the numerator, -22. The denominator, again, the way it is. At the tail end, we are seeing an answer, 11. And then the correct answer down there, -2. That value, -22 on the numerator is correct. 11 on the denominator is correct. -2 is correct. But this student loses this mark because the mark is not given at that point. The mark is given as shown by student B. Look at the way student B has performed his work. At the point where you end up with one operation, there are 2 scenarios there in the numerator, either -8 minus 14 or -13 plus -9. So any of them will earn you the first mark. So in -8 minus 14, the operation remaining there is the subtraction. In -13 plus -9, the operation remaining there is addition, earns the first mark. On the denominator, where one operation is remaining, is at the point 9 minus -2. That is where the second mark is earned, then the final mark. So you look at these students, yes, they have the same values, but student A fails and student B gets everything correct. Because in student B, there is evidence of use of body mass. You have eliminated the other signs, the other operations, you are remaining with only one operation, step by step. So let our candidates be very keen. Leaving answers in unsimplified form. Again, this is where students easily miss marks. A common question, very simple, but sometimes students mess up. They don't get all the marks in this question. what happens? They leave their answers in unsimplified form. This is what happens. We have a student A. This student A has done, this student A has done his work, and in doing his work, he is getting, just a minute. Now, student A has done his work. He has displayed the numerator, the denominator, the numerator 9/6, the denominator 9/10. Then he's combining, and he's leaving his answer as 1 2/3. That's where the answer, the last mark is. But look at student B. Student B does everything correct, but leaves the answer at 5/3. Does not get it. That is an improper fraction. It is not simplified. So encourage our students to always leave their answers in simplified form. If it's an improper fraction, let it be a mixed number. And sometimes you can get terminating or non-terminating decimals. So when a student in the evaluation gets a non-terminating decimal, it is advisable leaves that answer as a mixed fraction. If it is a recurring decimal, should indicate the recurring part. Otherwise, again, leave the answer as a mixed fraction. Now, rounding off errors in approximations. Rounding off in errors and approximation. Look at that question. That the area bounded by a curve is estimated at 21 square centimeters using the trapezium rule. But then the exact area by integration is 21 1/3 square centimeters. They want the percentage error in the estimation. Student A has done it and gets the answer. So it is either 1.5625 or as a fraction, 1/9/16. Remember, 1.5625 is a terminating decimal, accepted, can be given that way, or that mixed fraction that is given there gets all the marks. But then we have student B. The answer, because maybe he still remembers that we've talked of 4 significant figures, must work with 4 significant figures, present 4 significant figures. So he decides he's giving it 4 significant figures. That answer is not acceptable because it introduces another error. You have rounded off. So let them be very, very keen when looking at scenarios like this one here. Use of protractor in geometric construction. When a protractor is used instead of the procedures we know of angle construction, the candidate loses the mark for that construction. And this does not augur well for those students who want to score an A, because this mark you lose here can reduce the number of marks you score, and you end up scoring a grade less than what you expected. So let them be advised that the protractor used, you will not score all the marks. You will lose 1 mark. So let them be very, very careful. We cannot afford to lose marks easily when we are looking for that grade. So the use of the protractor, let them be careful about it. Let them learn these basic geometric construction ideas, and it will go down well with them. Evidence of factorization when simplifying composite numbers. An example, in one of the exams that was tested, you have 49 raised to power 3 over 2. You are multiplying by 256 divided by 2,401, and all that is raised to power 3 over 4. Students can easily make mistakes here because these things, you can punch them in a calculator and get those values. And students may think that examiners will not notice. Let them be very, very careful. Because if evidence of factorization when simplifying is not seen, they don't earn a mark. For instance, this student A, when you look at the cycled work, that is evidence of factorization. And this evidence here is what now enables you to earn the first mark. Then from there, all the other marks you will earn as long as you are accurate in your working. So this evidence is very, very important. Let our learners be advised, because they'll behave like this student B and they end up getting nothing. Because here, no evidence. Where is this one coming from? Is it off head? You know, there are some values that you cannot find off head. There are some values that there is a procedure to be found. So when a student behaves like this, a very simple question like this, but just because he's not showing evidence of factorization, loses, like these are 3 marks. No, you cannot afford, or you cannot carelessly just lose marks like this because maybe you are in a hurry or you are carelessly using your calculator. Let our learners be advised accordingly. Pi given in the question. Again, a very common question. And in this question, there is take pi to be equal to 3.142. There is use pi 3.142. The examiner is putting this so that there is a certain or a specific answer that the student should get. So when a student does not use or does not take the pi given, will get a different answer, which may necessarily not be wrong. But because he has not followed instructions, he will not get the prescribed answer that will arise from the use of that pi. As seen by this student here, student A has done everything and he's getting his answer. That is the accurate answer, 962.12. And he has taken the pi that was prescribed. Student B decides to use his own pi, and in this case uses 22 over 7 and gets a different answer, because this answer, this is 961.67, and yet here the answer is 962.12. This is the required answer. But now student B gets 961.67, which is a wrong answer that either the marking scheme or the examiner did not intend to have. But on the flip side, the examiner can be lenient and decide that the learner, you follow what the learner has used. But it is advisable, let us just train them to use whatever has been provided and not using their own, because this leniency sometimes may not be there. It depends. So let them be very careful. Let them be advised. Use of the term hence. Very common and basic question. Construct triangle. You have everything. The angle has been given. In that question, and I want us to take note of this, draw a perpendicular from C to meet AB at this point. Then further measure AD. And then you're told, hence calculate. So a student will do the construction. The construction is there. We'll finish that construction. We'll measure. We'll have all those measurements. Then there is the point of hence find. Remember, you've drawn a perpendicular. You have measured the perpendicular. So what that question expects you to do is to use that perpendicular height. That's why the word hence is there. Student A got it correct, interpreted correctly, and he's using that formula for finding area, gets the correct work. But now, student B, because wants to feel he's a hero, he knows all the formulas of calculating area, wants to become complex, and decides to use a half AB sine theta. It's not wrong, but he has not followed the instructions. So loses marks just because he is not following the precepts of that question. The same to student C. This one, now he's a hero because, you know, he's even using the hero's formula. But don't show us or don't show the examiner how much you know these things. Simply follow what the examiner wants you to do, and you earn all your marks. Because I'm imagining this one who has gone ahead and even did all these things, come and get that answer and lose everything just because he's not following the demands of the question. It becomes a little bit painful. So let them be advised that follow the question the way it is, and you will never go wrong. Allow me to proceed to statistics, but I hope as we are doing this, you are taking note of areas which we shall address at the end of this presentation by way of your action, I mean your questions. So let us proceed. Statistics. There is data there. Now, questions will come after this data. The first question, starting with the class 35-39. Make a frequency distribution table for the data. Then draw a histogram to represent the data. Then draw a frequency polygon to represent the data. Those are the questions that we have. Now, we are supposed to come up with a frequency distribution table. I always advise students, it is always easier to come up with this frequency distribution table when you involve this column of the tally. Other than going back to the table, crossing figures, and sometimes once you've crossed all those figures, you come and get your frequencies. Your frequencies are not adding up. You are supposed to go back to that data. It is dirty. You can't see anything. It becomes cumbersome and tedious. But if you can develop this tally column here, it will become easy. Look for an item in that data. Where does it fall? In which class does it fall? You put that stroke in that column. Get the next number. In which class does it fall? Put a stroke in that column. That way, your work will be easy. and you will have an easy time in finding or in generating that frequency distribution table. Then after you have generated that table, the question is, draw a histogram. Draw a frequency polygon. What are you supposed to do as a candidate? The word draw means use a ruler, not freehand. Because sometimes it's unfortunate, we meet students, we will see students using freehand to draw a frequency polygon. They are using freehand to draw a histogram. It is not right. Draw means use a ruler. It must be a straight edge. It must be a straight line as you draw. Then, in drawing this histogram, let us look at maybe 3 cases. Case number 1, where classes do not start with 0. What do we do in such case? And the data there shows that kind of a case. Our class here is beginning from that. So we are saying for such a case, start the horizontal axis at the lower class limit of the first class. Then from there, you can plot either frequency or frequency density against the upper class limit. Then join those points, get your bars correct, and you're good to go. As shown in that diagram, we are beginning at the lower class limit of the first class. Then we have our values. We have those bars uniform like that. In this case, frequency density has been used. Or alternatively, instead of beginning the horizontal axis at the origin, you can break and start somewhere. As long as the value you are starting with is the lower class limit of the first class. And then draw, make your bars uniform, and you have your marks. Case number 2, we have data or classes that start with 0. For instance, this one here, this begin the first class 0 to 9. When data is like this, start the horizontal axis at 0. And then make the scale uniform. Once you make the scale uniform, it is simple. Now that you know we are drawing a histogram and we need the upper class limits, you can easily pick out an upper class limit. So please, when data like this, begin your scale at 0 as shown and proceed accordingly. Make your bars uniform, the scale is uniform, and I hope you can be able to see clearly. The upper class limit for the first class is 9.5. It has been located, and those bars are like that, correct. There are some cases where the class size is not uniform. When the class size is not uniform, the only difference will come in is this. You will be required to use frequency density as you plot your, or as you draw your histogram. So where classes, the sizes are not uniform, please generate a frequency density and use it against upper class limit and have your histogram. On the frequency polygon, create a class before the first class whose size is the same as the first class. Then create another class after the last class whose size is the same as that of the last class. And remember, these classes that are created, their frequency is 0. This will enable your frequency polygon to anchor onto the horizontal axis. Otherwise, if it does not anchor, if it remains hanging, it is no longer a frequency polygon. Because in the first place, it is no longer a polygon. Because we know from definition, a polygon is a plane figure bounded by 3 or more sides, should be bounded. But when it remains hanging, then it is not bounded. So our data will look at this. Remember, our first class was 35 to 39. So we create a class whose size is the same as this one here. So we create 30 to 34 at the beginning, but the frequency for that class is 0. Then at the end, we also create another one. Remember, our last class is 75 to 79. So we have created 80 to 84, same size as this one. But again, the frequency there is 0. These are enabling enabling us to draw the frequency polygon. And remember, a frequency polygon, you plot it against midpoint of classes, then you join those points with a straight line. And then remember this, that you cannot draw a frequency polygon on a frequency density axis. This is a frequency polygon. So it is frequency, but not frequency density. And this affected some students in an examination where a question came and you're supposed to draw both a histogram and a frequency polygon on the same axis. So they went ahead, got everything correct, even the histogram correct, but those who used a frequency density, they missed that mark of the frequency polygon. So let them be advised also. So that's how now our frequency polygon will look like. You see, we have anchored this at the midpoint of the first class. So very, very important. The last one is anchoring at the midpoint of the last class. Otherwise, without this, your graph would hang. Without this one here, your graph will hang here. And when it hangs like that, we have said it is no longer a frequency polygon. So kindly let this information sink in our candidates as they prepare for exams. You've been asked to complete a table. You are drawing a trigonometric graph. Please complete that table to the number of decimal places indicated by the examiner. Very, very important. Some students miss that. I don't know what normally happens, because you encounter students who don't see. They don't understand the language in the question. They fill that table carelessly, filling to any number of decimal places, or sometimes they are decimal places, but this student fills whole numbers. So let them also be advised. Then sometimes these questions, they ask you to find the amplitude, use the graph to find the amplitude. Kindly, they need to know that for them to get the amplitude, they need to draw a line showing the mean position. And how is this done? Let us see. That table is there. The values of y in black, those are the values of the examiner. So the examiner is speaking that these values, please fill them to 1 decimal place. In fact, they even told you, complete the table below for that function, correct to 1 decimal place. Hello. So this student has filled the table correctly.
Senior, hold on. Hold on.
Yes.
Someone has interrupted the session, and I think that is Musundi. Kindly, when you want to speak, you raise your hand, or maybe as the presenter said, you wait until the end, please. Okay, carry on, sir.
All right. So this student has filled this table correct to 1 decimal place, and now he goes ahead, and the question there is to draw the graph. The graph is drawn as shown. The smooth curve is seen. Now, we want to use that graph to state the amplitude. Use the graph to state. So the instruction is use the graph. So how do you go ahead to use that graph? This is what happens. Get the average of the maximum and minimum points of the graph. When I look at the graph that we have drawn, the maximum point y is 4. The minimum point y is -2. So the average of that gives you 1. Y is 1. So draw the line y is equal to 1. Once you've drawn that line, as shown in that diagram, then the amplitude is located as shown by the line there and indicated A. So you get the amplitude from here. And according to that, our amplitude is 3. That's how you use that graph to get the amplitude. Sometimes it's not about the graph. You've been given a function and they're asking you state the amplitude of that function. The function we have is as shown, y is equal to 1 minus 3/2 sine 2 theta minus 30. How do we get the amplitude? There is a student who writes the amplitude as 3/2. There is one who writes 1.5. The one who has written 3/2 does not get it. Remember from the instruction earlier on, your answers must be simplified. So at 3/2, you don't earn that mark, you don't get it. But at 1.5, you get the mark. So let these students be advised. Now, solids. Solids are common questions in our exams, but students lack the skills on working out solids. And these are skills that can be developed just the same way we said about construction. Let them develop these skills. In solids, hidden lines are drawn using broken lines. And you
just a minute, sir.
Yes, please.
Kindly, sir. Interruption. I'm missing a screen. I'm missing the screen on my part. Huh?
You're not seeing your screen.
Presentation on the screen.
Or you're not seeing it.
Yes. I'm not seeing it on my part.
Okay, the screen
is, and everybody and other people.
The screen is okay. When someone is not seeing the screen, the network on this side is a bit weak. You cannot be able to watch that screen if the network is a bit unstable. It's very visible.
Oh, okay. So, sir, please maybe check your network so that we move together. So I believe I can proceed. Now,
yes, carry on.
So we've been saying that
yes.
Draw hidden lines using broken lines, and then parallel lines must be drawn parallel. And so they know, let us teach them how to use various ways of drawing parallel lines so that they can be able to get these things correct. An example is this. We have a diagram the triangle is shown, uniform cross section. BE is one of the edges. You've been told to complete the sketch. So you've been given part of a solid. You want to complete the sketch. That is the solid you have. That means the edges AB, AC, and BC, these are seen. But the edge BE is hidden. That's why we have drawn it using a broken line. So when you complete that, this is how it is supposed to appear. The edge BE broken because it is hidden. EF broken because it is hidden. ED broken because it is hidden. And CD, AF, BE are parallel. FD, AE parallel. BC, ED parallel. Then a student gets the marks. And let them avoid dirty work when it comes to this. Because sometimes when you draw several lines, it's not easy to see which line is the correct line that you intend for award of marks. Nets do not have broken lines. When you open up this solid, it gives you a net. Remember, here we have broken lines, but nets do not have broken lines. Then the labeling again must be in order. Otherwise, wrong label, that means wrong net. So let our learners be advised. Allow me to touch something on transformations. And this is where some of our students lose marks. They have done graph work. They know that maybe a scale on the horizontal axis can be different from a scale on the vertical axis. But when it comes to transformations, the scale on both axes must be the same. Then they should not use broken lines for images. And then lastly, the diagrams must be labeled. Why are we talking of the same scale on both axes? Look at this case. This is a square. That square, you see, the scale on the horizontal axis is the same as the scale on the vertical axis. It gives you a square. The vertex A, the coordinates 1, 1, B, 5, 1, C, 5, 5, D, 1, 5. But if you use different scales, look at the same square. It now appears a rectangle. That's why it is important that these learners should use the same scale on both axes. The moment you use different scales, it changes the diagrams we have, it changes the object. You will not get the correct transformations taking place. So please let learners be advised on that. Very, very important for them. What are some of the emerging trends in the setting of Math Paper 1? This is what we saw in the beginning, that more emphasis is placed on Form 1, Form 2 work. If the trend we have seen when we began is anything to go by. So if learners will want to excel and do very well, if they can oil their work, oil their fingers, oil their brain in Form 1, Form 2 work, they can do extremely well in Math Paper 1. We had seen this earlier, even this one we had seen it earlier, so let them be advised. Same to this, that in Paper 1, Form 3, Form 4 work that is tested, those matrices, trigonometry, sine and cosine rule tested, differentiation, and area approximation. I want to advise learners as I wind up. Let them take personal responsibility for their performance. Teachers can do their bit. You can wake up those wee hours of the morning. We can do late nights, but the student should be willing. The student should accept. The student should be able to stand and say, it is my responsibility to perform. If that can be done, our students are going to do well. If our students are going to minimize or eliminate the mistakes that we have seen as we have developed, then we have a long way and we shall do very well in mathematics. Like those who heed our advice in the first webinar, I think they felt well when the exams came and they did well. So for the candidates of this year, I want to wish you well. I want to wish you success, and may the favor of God be on you as you sharpen your skills. And my colleagues, may also the favor of the Lord be on you as you guide and mold the students to success in the exams. Thank you. Thank you. Thank you for today.
Thank you so much, Makofi kwa presenter. Let's appreciate the presenter for the good session we had. Actually, this is pure learning, and we are learning a lot. This is very pure learning. So, dear colleagues, I like now, let us raise our hands. I will call you. The rest to be muted. Just raise your hand. I'll call you and ask us a question. Na ukisikia mwalimu ameuliza swali nyingine unataka kuuliza, lower your hand. Let us not be repetitive, and also let's observe the time. Okay. We'll start with Paul Musungu, Teacher Wesley, then Susan Ngugi, in that order.
Okay, this is Paul.
Yes. Carry on, Paul. Paul, are you muted?
Okay, I'm saying,
Yes.
Yes.
Is it possible to share this information you have taken us through on the wall?
Or you're asking about the information?
Sharing it on the page.
Sharing, okay.
Yes.
We address that one. Teacher Wesley? Teacher Wesley? Okay, Madam Susan Ngugi. Madam Susan Ngugi.
Good evening.
Good evening.
Yeah, I have one question. The question is, there's somewhere he talked about, I think I didn't get well, where you are supposed to show factorization. I was wondering if something is simple and a student can do very fast, like I know I can get 49 is 7 to power 2. Must they show where they have worked the factorization or the working process? That's number one. And the other one is on rounding of array. When a student is solving a question, how does it affect? Because a student may round off and do all the other processes. If a question is a fraction, can you give it in decimal? If it is in decimals, the integers, can you give in fraction the answer? And those are my few concerns. Thank you.
Okay, I think Sina, you can answer those.
Thank you, Madam Ngugi, for those questions. Now, the first question on factorization. I said, or I talked about evidence of factorization. There are those values that are simple, like, for 49, that one is easily done. But there are those that are complex. Those ones that you either must use a calculator to get the values. So those ones are the ones that we insist, let us see. But something like 49, that is something that can be done offhand, and a student can do that very fast. But those complex and big composite numbers, those ones must, evidence of factorization should be seen. Like it is zingine ndogo ndogo, like 4, you can easily factorize 4, 2, and 2. That one offhand, it can be done. I hope that one is answered. 2 on rounding off.
Mm-hmm.
We talked about premature approximation.
Mm-hmm.
Let me just get the screen. That is the working. I hope you can be able to see.
Mm-hmm.
Now, look at the value AB.
Mm-hmm.
The value AB is 6.38551.
Mm-hmm.
Now, this student has done it without those premature approximation.
Mm-hmm.
But then student B does it. And he's having, remember, AB is 6.3851. But now he's rounding off to 3 decimal places. So at that point of rounding off, this student is booked for premature approximation, because our working should be to a minimum of 4 significant figures. At this point, this student is using 3 significant figures. Yes, he gets the answer, but because he used less 4 significant figures, premature approximation, then he will lose 1 mark. The worst case is this student C. This one has even rounded off to 1 decimal place. It has totally changed the value that we had in AB. And that change is even affecting the answer. Because our answer, remember, is supposed to be at 7.7. But now, in using this, is getting at 7.8. Yes. So these are the effects of premature approximation. It can affect the answer at the end of the question, and a student ends up losing those marks. I hope we are good to go there.
Yeah, there I'm okay.
Then on fractions, we recommend that if they are non-terminating decimals, present your answer as a mixed fraction. If it is a fraction, but you realize it is a terminating decimal, you can present your answer as a terminating decimal. Like, let's say, for example, 3/2. When you divide 3 and 2, you get 1.5. So 1.5 is acceptable. Again, 1.5 is acceptable. And if it is a recurring decimal, like let's say 1.6 recurring, should indicate the 6 recurring.
You put a recurring? Or
Yes, you put a recurring, that dot or whatever you use.
Yeah, the dot, yeah.
Yeah, that dot, you put it there to indicate it is recurring, it is acceptable.
Okay.
Yes. Karibu.
Hello, sir. I have 2 questions.
Yes.
Number one is premature
excuse me.
approximation is there on the screen.
Excuse me, Lewis. We are not going like that. You raise your hand. That's what we agree. If we go like that, we are going to be chaotic. So the next one line is Simon Oya. Simon, can they ask you a question? Okay, let's go to Eric or Terry. Eric or Terry. Byron Omari.
Yes, good evening.
Good evening.
Good evening to
Yeah,
you.
I have a number of questions, but first I wish to thank Sydney for a very good presentation.
Thank you.
I'm starting with a question on the emerging trends.
Yes.
In the recent years, we've seen questions on tables not appearing, use of mathematical tables. What could be that suggesting? What should we do as we prepare for the same? Secondly, you talked about finding the amplitude and doing it correctly in trigonometrics. I wanted to be enlightened on. Sometimes you are asked to find that K or C. I believe that represents the phase angle. What do we do with that? Then my last question, I believe, is on statistics. Sometimes we are asked a question on using the histogram to show the median. Can you please shed some light on the same? And on the same, if a data starts with 0 and we are asked to maybe draw a frequency polygon, where do we anchor? Where do we anchor? Because you said we create a class just before the first class and the end. So where do we anchor in case we cannot have such cases being tested? Thank you so much.
Thank you for your questions. The first one on the emerging trends, the tables and stuff like, I may have very limited information on why maybe NEC is moving away from questions on tables. But what I can say is you'll find that those tables, eventually at the end of the day, they are used because there are some constants in that table that students can use. I know with the advent of the calculator, most of these things can be done in the calculator. So as technology is advancing, maybe with the time, these tables maybe will be phased out. Because if you remember right from the old days, we used to have things like slide rules. So, and you realize that when now mathematical tables came in, those slide rules became obsolete. So maybe with the time, these tables may again be done with. But as per now, there are those constants that are there and still useful, and maybe that's why the NEC is still insisting on use of the tables. We cannot rule out that they can no longer set questions that are using tables because it is still in the syllabus, and even the next syllabus itself dictates that we should teach use of those tables. The amplitude on trigonometry. Are you still online? The originator of this question.
I'm listening.
Yes, there's something. Just remind me with the amplitude. What about the amplitude?
Sorry, I'm saying.
Yes.
In case you are asked to find the amplitude using amplitude, I got your point.
Yes.
But there is that part of the last part, finding the first angle, I believe so.
The first angle.
Yeah, using the diagram and such.
Using the diagram.
Yeah.
Now, I hope my theory will be able to link and see when you draw those two graphs.
Yes.
When you draw those two graphs,
I'm getting
at the point where they are in phase, at the point where they are in phase, then the difference in the values of x at the point where they are in phase, that gives you the phase angle.
Okay.
Yes. So simply check for the point where they are in phase and get the difference in the values of x.
No problem. Thank you.
Then on the use of the histogram to find the median, what we need to understand is that the area covered by the histogram is the frequency. So all you need to do is you take the frequency, the frequency you have, the CF, or the total number of items, simply divide them by 2. Once you have divided them by 2, that will give you half the area of that. Like, allow me to use maybe a data that has 30 items, right? 30 items, and we want to find the median. We'll divide 30 by 2. So our median will be at 15. So we shall start counting our area. Remember, histogram has bars. So each of those bars should add up to 15. So you will add the areas of those bars or the frequencies up to where? Up to the bar that is slightly less than 15. Then once you have that, the remaining part to get to 15 will be found in the next bar. So at that point, like let's say, for example, my first bar, let's say, for example, the frequency is 5. The next bar, the frequency, let's say, is 7. When
the
I
screen
add,
is not.
oh, okay, I have not prepared this, so I was just trying to talk to him theoretically. We see.
I'm getting it.
Pardon?
It's I'm getting it clearly. Yeah?
Are you getting?
Yes.
So we are saying maybe the first frequency is 5, the next is 7. When you add 5 to 7, you get 12. And you realize that 15 is what we are looking for. But when you add that frequency that is next there, it goes beyond 15. So you will stop at 12. But then get into this bar where the next frequency is. So in that bar where the next frequency is, you will get the width of that bar, because the height is definite, it is there. So the width of that bar and the height given, this width you will assume because you don't know it. It can be H, it can be W. So that width and this height should give you the remaining frequency, the difference between 15 and 12. Remember, we had come up to 12. So the width and the height, the product should give you the difference between 15 and 12, which is 3. So you will get the value there. That value you get, you add it on the upper class limit of this bar that ended at 12. And that gives you the median.
Thank you.
So unless, I don't know if, I know tomorrow again is charged, but if I find time, maybe I prepare that slide and borrow 1 or 2 minutes from tomorrow's session, then I can show you.
Thank you so much. I've gotten your point.
Karibu.
Okay.
Moderator?
Brian Odongo. Brian Odongo. Rogers Kisongoch.
Kindly, please, I'm back. Hello?
Yes.
Kisongoch.
This is Brian Odongo. Kindly, please.
Okay.
Yes, yes, yes.
Thank you. I had a question on when you are drawing trigonometric graphs, and maybe you've been asked to find the value of x in which, say, maybe the curve y maybe is equals to 2 sine x is greater than the curve y is equals to cos 3x. And maybe you have the point of intersection of the two curves is negative 90 and 90, and you're maybe told to get the range. How are you going to write your range? Are you going to write it in form of an inequality, or you can even say from negative 90 to positive 90? Thank you.
Yeah, thank you for that question. And I think what you're saying is you can write it in form of that inequality, as long as you're indicating the range, right? It can be negative 90, then less than or equal to x, less than or equal to 90, or simply write negative 90 to 90 degrees. That's how you indicate the range.
Okay, thank you.
Karibu.
Rogers, let's move fast. Rogers.
Okay, thank you for the opportunity. I would like to inquire one, that is on statistics. I don't know if you're getting me.
I'm getting you.
There is, I'm getting this, that if we are drawing the frequency polygon,
yes,
you have told us that it has always to be frequency against the midpoints.
Yes.
But sometimes we have been given a histogram, and we want to draw the frequency polygon on the histogram. So how do we go about it? And the histogram, maybe the data we are having is having different sizes.
Okay. From the inception and from characteristics and definition, a frequency polygon is that data that shows the variation between frequency and the midpoints. So with that in mind, and when you look even into the archives, you will find that whenever a question is coming to superimpose a frequency polygon on a histogram, then the classes that are provided are always uniform, because you cannot have frequency density against midpoints and then you are drawing a frequency polygon. And remember, this thing affected quite a number of candidates last year, because sometimes candidates are used to drawing a histogram using a frequency density versus the upper class limits. But then it happened that those who used a frequency density in drawing a frequency polygon, they missed the mark for the frequency polygon, because the vertical axis has frequency density. So it is advised that when you are drawing a frequency polygon, please, it's supposed to be frequency against the midpoints. Or conversely, we understand that the area of those bars is proportional to the frequency. So instead of, even if the sizes are not the same, then all you need to do is you will now work on the horizontal axis to get the correct. You can still have the frequency on the vertical axis, but then because of the sizes of the class, then it must be created so that it reflects or it is proportional to that frequency. And that's why ideally frequency density, if we can take note of this, that frequency density is a constant multiplied by the frequency over the class size. So this idea, this relationship here that the frequency density is directly proportional to frequency, but inversely proportional to the class size. So we need now to play with the class size so that we have the correct frequency as we plot that. But you know, that one is a little bit tedious and it's hectic. And that's why you'll find that most of these questions that require you to superimpose a polygon, a frequency polygon, and a histogram, most of them will come with a uniform classes. But in the event the classes are not uniform, then you will employ this FD is equal to K over F. I mean, K is equal to K F over W. It will help you to get the correct classes as you plot so that the frequency polygon can be plotted on a histogram where the classes are not uniform.
Lewis,
I hope I've helped somebody.
Okay.
Yeah.
Good evening.
Good evening.
I have number one. Please, unlike you just enlighten me on how to get the translation vector from the trigonometric waves. Then secondary, the premature approximation on the screen which you are still sharing. What if a student uses 6.385? That is 4 significant figures. Will that make him or her lose the accuracy? Answer mark, the final mark. Then finally, there is this question of longitude, and there is much concern about finding the distance around the great circle. There are some instances when you find that the longitude are not 180. And there's a formula, this one for sine and cosine, a small formula which is normally used in such cases. Is it allowed in marking? Thank you.
Thank you. Now, the translation vector when it comes to trigonometry. Remember, when you're drawing trigonometric graphs, it is the values of y, which are trigonometric ratios, against the angles. So when a wave is translated from one form to the other, it depends on the direction of the translation. So it will vary according to the angle that is given and according to the trigonometric ratios corresponding to that angle. So like, although I don't have a slide like that to show, but if you have a wave, and let's say a wave has been translated by 30 degrees. So the translation vector, remember, a vector takes place, you take the x direction first, then followed by the y direction. So this magnitude of 30 will be written as 30 degrees. You write it as a column vector. So you write 30, and then below 30, maybe there is no variation in the y, it will be 30, 0. So the translation vector becomes 30, 0. Then 2, on a premature approximation, if the student is using 6.385, he's using a minimum of 4 significant figures, which is allowed. And therefore, it does not warrant to be booked for premature approximation, gets all the marks as long as the work of that student is correct. Then the longitude difference, when the longitude difference is not 180. Yes, I believe that formula is used, because that question was there some time back, although it has taken some time before we've seen it, but it is there. Although I want to believe people of paper 2 will shed more light on it tomorrow, kindly.
That was Kcse 1995. Let's go to Margarine, guys. Magarini girls. Maulidi.
Ongea, uliza.
Excuse me. I had a question.
Yes, please go ahead.
My question was.
Yes.
So, if a person writes his work or his work on the section, then after canceling the question, he realizes that the space provided is not
Please,
enough. Then he
can you reduce the volume? Hello.
is not marked or it is penalized.
Hello. There is some noise. There is some noise. There is some noise. Have you connected on a speaker? I can't get you clearly. Hello.
So I was asking.
Yes.
If a student writes his work on the section provided,
yes,
then he cancels the work after knowing that it is wrong.
Yes.
Then when he started doing the second formula, he realizes that the space which I've left is not enough for the whole formula. Then he indicates there, mark at the, is that work penalized or it is marked as the way it is?
No, it is marked as it is. It cannot be penalized. As long as he has given direction, then it is marked as it is. You can't penalize a student for such. As long as he has given direction that this work has been done here, followed up and marked.
Okay. Sawa. Felix Lamai. Let's observe time. Felix Lamai. Okay. Simon Oya.
Thank you, sir. I've got a question on this matters to do with sine rule, cosine rule. Sometimes in the question, a student is directed to calculate some lengths and give the answer in 2 decimal places.
Yes.
Let's say if a student calculate a length maybe AB in 2 decimal places and find it as 5.13.
Yes.
We know that that is not 4-figure. Then, if in any case this length is being needed to work out the next question,
yes.
So will this student use this 5.13 to work out the next question, or is he required to use the 4-figure number? My second question is on matrices.
Yes.
More so in solving simultaneous equations.
Yes.
After a student has got the inverse.
Yes.
Is it a must that this student show the left side, which normally ends up with 1001?
Yes.
Yes, and then my last one is on the statistics. Maybe there was an error in generating the frequency distribution table. And this student ends up using this table correctly to answer the questions below it, like mean and median. Will these students be awarded marks or not? Thank you.
Thank you. To the first question, the question itself demands or has asked the student to present his or her answer to 2 decimal places, and the student does that. Those are the specific instructions of the question. this student will not be penalized if he uses these values, because that is what the question wants the student to use. So there is no penalty for such. That's why we say that the student must be keen on the specific instructions in a question. Because whoever now in this case, he tries, because we have talked of 4 significant figures and tries to come up with 4 significant figures, I don't know what kind of figure he will come up with. We will add a 0, 0 at the end there, but there is no need. There is no penalty for such. 2, your question on matrices solving simultaneous equations where the inverse is. The pre-multiplication matrix, definitely on the left side, it will give you 0, 1, 0, 1. And then what is important is that pre-multiplication of that matrix by the constants matrix. So although it is normally, we simply teach pre-multiplication on both sides. But what is most important is that pre-multiplication of the constant matrix by the inverse of that matrix. Hiyo ndio kitu ya muhimu.
Okay.
Then you are talking about the error in, please, if you can come up again.
Yes, I was saying if a student was generating a frequency distribution
Error
table.
in generating a frequency distribution table. Like, let's say,
Yes.
for instance, the classes is making those classes, then messes up in the classes.
Messes up in one of the classes in terms of frequency.
So he messes up in the frequency. So that mark for the frequency is lost. And that mark for the frequency, when it is lost, it means that, like, let's say if he's getting the mean, there is that column for fx, again, that column will be wrong. So he will not get anything correct there. He will lose.
Okay, thank you.
Yes.
Chris Wabomba.
Hello, senior.
Yes, sir.
Yeah, this issue of the upper limit and the class boundaries.
Yes.
I thought senior maybe he exchanged the two when drawing the histogram.
The upper limit, I mean, the limits and the boundaries.
Limits and boundaries, like for example, a class of 30 to 40.
30 to 40, yes.
So 30, according to me, 30 and 40 are limits.
Yes.
Then 29.5 to be the boundary, and maybe 40, something like that.
And for this will be 40.5.
Yeah.
So according to you, 30 and 40 are the limits.
Are the limits.
And
yes.
29.5, 40.5, those are the boundaries.
Those are the boundaries, sir.
Now. So in this case, according to you, 30 is the lower limit.
Yes.
And 40 is the upper limit.
Yes. I don't know which edition of KLB is explaining it that way. Then there was also a question on Kcse, should be paper 2, statistics, the lower boundary.
Yes.
It was around 62 point something, 0.5.
Yes.
Yes.
Now, I think we need to explore this one further. We need to explore it further, because whatever you are thinking, I also used to think so. But then somebody came and convinced me that it is the other way around.
Yes.
Yeah, but now we are on the floor here. I think we can explore this further and find out, so that we get a firm decision on which one is the limit and which one is the boundary.
Yes, okay.
Sawa.
Felix.
Okay, I'm having a question under transformation, whereby you'd like to ask, how would you find the shear factor given during that kind of equation?
Paper 2 man.
the shear factor. Now, the shear factor, I want to give an example. Let me use an example. Like point A, 1, 2, is mapped onto point A prime, and point A prime is 1, 4. The shear factor, get the displacement, and the displacement here will be 4 minus 2. I hope you got those coordinates. I'm using them as an example. Saying point A, 1, 2 is mapped onto point A prime 1, 4. So to get the shear factor, it is the displacement 4 minus 2 divided by the distance from the invariant line. And according to these coordinates, the distance from the invariant line is 1. So it is 4 minus 2 over 1, and it gives you 2. So our shear factor there is 2. So it is simply the displacement in the direction of the shear divided by the distance from the invariant line. I hope I've answered you.
Yeah, you have answered. Thank you so much.
Karibu.
Madam Naomi?
Statistics 1. Are you getting me?
Yes, yes.
Yes, yes, go ahead.
Yeah. In questions where a student is supposed to come up with a frequency distribution table from given data, let's say the list mark is 38.
Yes.
And the first class is not given, and maybe the class size is given as 5.
Yes.
So one student can do from 38 to 42. And another one can do from 35 to 39. So say something about that. Then number 2.
Yes.
What Mr. Wabomba was thinking about limits and boundaries, actually he's right. When we are given a class size or a class limit from 14 to, or from 10 to 14, from 9 to 14, that is a class size of 5, 9, 10, 11, 12, 13, 9 to 13.
Yes.
That one is class limits. You can actually exceed a limit, but you cannot exceed a boundary. And that is why when we are given 9 to 13, those are limits, but 8.5 to 13.5, those are boundaries.
Those are boundaries.
And in statistics, when we are given boundaries, the boundaries are continuous. There is no gap between one class and the next one.
One class to the other, yes.
10 to 20, 20 to 30, 30 to 40, 50 to 60, those are boundaries. But 9 to 19, 0 to 19, 20 to 29,
those are now the limits.
these are now the limits.
Okay,
so I wanted you to shed some light, or anyone to shed some light on when we are given this data where we are supposed to group ourselves and the first class is not given, and the list item is 38. So one student can do 38 to 42.
Yes.
Another one can do 35 to 39.
Maybe on a light touch there, how I wish that, and from experience, from what you have seen, whenever they give that list value for a data, that is the value we begin with. Then you create like this one here, the list value in that data. When you look at it, the list value is 38. So, and a class size of 5, that means this will take you to 42. So I would advise that when given such a situation, then we pick that list value. Because we've seen from experience that whenever they give, they tell you that like this value here, like 38 has been given, and then starting with the least value in the data, and a class size of maybe 10 or 5, make a frequency distribution table. So my advice will be, let this list value that has been given be used as the first or as the limit for the first class. It will be easier that way.
Thank you.
Karibu.
Thank you. Kindly show me that screen for construction. I needed that question. Construction and the word hence.
Construction.
Okay, Brian Ocheng, you can come in. Okay, Benson Otieno.
All right. Thank you again, Senior. I've really learned a lot. Now, I wanted just an inquiry still on statistics.
Yes.
There are some cases where you have the class is given maybe from 1 to 5, 6 to 10, and so on.
Yes.
Then we want to plot a frequency polygon using the same data. If I find it's from 1 to 5, so if we are to add a class lower,
yes,
would we go to the negative, or what will you do? Then number 2, I joined a bit late, so just a request, if you would share the slides, I really appreciate. Thank you.
Karibu. Now, we are talking about a frequency polygon on a data like this one here. You're talking of a beginning class of 1 to 5, 6 to 10. And we have said, if you want to draw a frequency polygon, this polygon must be anchored on the horizontal axis. Otherwise, it does not qualify as a polygon. Now, this one here may look like a new case because in statistics, negative data we don't have. I will request that we can explore this, and then when we find time, we can review it, because creating a class before 1 to 5, that means moving into the negative, because we need that midpoint there for us to do what? To get the frequency polygon. And now in this case, our data is limiting us. We cannot have a class that starts in the negative, because that statistics does not exist. So my request would be, as we explore, because we are all here, as we explore this, we can share and shed more light. I want to believe that the other experts who are here, we can explore this one further, because it is something strange that we've not come across.
Okay.
Asante.
Let me call in Brian, you.
Hello.
Yes.
Can you hear me clearly?
I'm getting you.
Thank you. Madam Naomi talk about the class intervals and class limits.
Yes.
I would refer, if anybody is having Oceans of Mathematics on page 110.
Yes.
On the page 115.
Yes.
So that we clearly understand between the class limit and the class boundary, because this thing is again another study.
Yes, they are confusing.
Yes, it is clear. Actually, I got learning this year in Oceans of Mathematics.
Yes.
I challenge any one of us to get a copy of the book and see on page 10, page 110 and page 115.
Yes.
And this one on what if the class is now getting to 0?
Yes.
0. My question is on what if the readings was on let me say on temperature readings, they go so to below 0. So in case of temperatures, if you get a data on temperatures of -5 degrees, -3, so what do you actually do about this? Maybe that's maybe a constant, because that is the only thing that can get us to below 0.
Oh, and by the, it depends. I think you are shedding even some more light there. It depends on the kind of data that you have.
Yeah, sure.
Like, let's say, for instance, if it is temperature, it goes to negative. Right? It can go to negative. But if it is mass or if it is number, then that one cannot go beyond. Yes, it cannot go into the negative. So I want to believe that in that case, it can be an issue of the kind of data that you have. Yeah, that data will dictate how the anchoring or how the creation of this class will take place.
Sure.
Sawa.
Thank you.
Asante.
Then finally, we have a senior Guri.
Thank you. So maybe for a point of clarification, from the boundaries and limits.
Yes.
Boundaries and limits. So the boundaries is for real classes. The real classes is where the upper and lower ends of two consecutive classes are overlapping. In other words, we normally call it continuous, like case is 2011, 100, 150, 150, 200. Those ends are called boundaries. Then where the ends are not overlapping, they are called limits. Then another clarification, I also talk about the drawing of the graph, that is statistical representative data. Number one, we need to consider the type of the data that we have.
Yes.
If you have the temperature, the thermometer can read up to the temperature side.
Up to the negative side.
But in mathematics, most of the time, they normally deal with marks and masses,
yes,
which cannot go back to the negative side. So in the case where you want to create another class, which is called a parent class, and it's taking you back to the negative, we anchor it at 0, because 0 is an absolute, at least it's convenient.
Yes.
When you check Kcse 2009, Kcse 2002, those 2 years, though it was in the paper 2 in drawing and archive, it was taking back to the negative when you are finding the lower boundary. So when you are finding the lower boundary and takes you back to the negative, you anchor it at 0 as your lower value for that class. Then number 2 clarification was somebody also talked about pre-multiplying the universe on both sides. My advice that if you want to multiply on the right hand side alone, a learner should be very keen, because in section 2, sometimes they can decide to give you the first part to find the inverse of the matrix. Then they want you to use that matrix to solve that part B. A good example was Kcse 2016, where you are to use that matrix A inverse to solve the matrix B. It will only happen so if and only if the matrix formed is the same as the element of the matrix you have been finding its inverse. If the elements are not the same, you need to multiply on both sides, because you might not end up with 1001. You might end up with another element, like 2016, they were ending up with 20, then 0, 2. Mean that they need also to go ahead by factoring out that 2 and divide by 2 on both sides. So let them just advise the student that pre-multiply on both sides. Thank you.
Thank you, senior. By the way, it is just important. It is just important that they pre-multiply on both sides. You never know of any eventuality, like the cases you have quoted. Asante sana.
Thank you for the clarification. Members, it is past 10. It's almost 10:30. Actually, it's 10:30. So I wish that we stop here. Any further question can be kept or shelved until tomorrow. There will be that room. You can just refer. The presenter of today will also be available tomorrow. So should you have any question, you can ask at that time, kindly. So at this point, I want us to end it here so that teachers can go to sleep, and also the learners, remember we had learners here, they can also go to retire. So I wish to call Madam Naomi if she's here. Yes, Madam Naomi, you kindly close for us today's session.
Hello, good afternoon, everyone.
Yes.
Close by a word of prayer, or I give a vote of thanks.
Vote of thanks, and
Okay, I want to thank the facilitators of today. The network has been good on my side. I believe it has also been good on your side. I also want to thank all maths teachers for finding time to attend, especially this time between 8 to 10 p.m. where we are supposed to be resting. That means we have a heart for our students. Okay, we can bow down and pray. Heavenly Father, we thank you for this session. We also bless you for the good health that you have given us and the resources that you have given us as maths teachers. We pray that you bless the work of our hands. And this night, we pray that you guide us and help us attend tomorrow's session in good faith. In Jesus' name I pray and believe.
Amen.
Amen.
Thank you. Thank you, everyone. May you all
Bye,
have
guys.
Good night.
Good night.